July the 16th, 1945. A desert in New Mexico is torn open by light. In less than a second, humanity enters a new era, not with a whisper, but with fire. But this moment, the Trinity test, was just the final spark in a chain reaction of secrecy, science, and sheer ambition. The Manhattan Project wasn't just about building a bomb. It was about building a future, or destroying one. How did we get here? Who were the minds behind it? And what does it say about science when it's harnessed for war? This is the story of the Manhattan Project, and you're watching Echoes and Atoms, The Spark, Einstein's letter and the fear of Nazi Germany. It began not with an explosion, but with a letter. In 1939, Hungarian physicist Leo Szilard, deeply concerned about recent breakthroughs in nuclear science, turned to one of the most famous voices in physics, Albert Einstein. Together, they warned President Roosevelt that Germany might be on the verge of developing an atomic bomb. A single letter set into motion a project that would employ over 130,000 people and reshape the world. Roosevelt responded swiftly. By late 1939, the U.S. government began funding uranium research. They called it the Manhattan Engineer District, or, as history would remember it, the Manhattan Project. Splitting the atom, the science of fission. In 1938, two German scientists, Otto Hahn and Fritz Strassmann, bombarded uranium atoms with neutrons and witnessed something extraordinary. The uranium split. It fissioned. A new form of energy was released, not chemical, but nuclear. Lisa Meitner and her nephew Otto Frisch soon realized this process released far more energy than any previous reaction. Einstein's famous equation, E U mc2, came alive. Mass becomes energy. And in fission, a small amount of lost mass produces a massive release of energy. If you could create a chain reaction, one atom splitting another and another, you could release unimaginable power. But to make that happen, you needed fissile material, uranium-235 or plutonium-239. Both rare, both hard to isolate, but both potential fuel for the first atomic bomb. The secret cities. Building the bomb. The U.S. mobilized like never before. Entire cities were created out of thin air, but kept hidden from the public. In Oak Ridge, Tennessee, massive facilities were built to enrich uranium. In Hanford, Washington, nuclear reactors were constructed to produce plutonium. And in Los Alamos, New Mexico, the greatest scientific minds were assembled to design the bomb itself. These places weren't even on the map. Workers had security clearances. Letters were censored. Even most scientists didn't know the full scope of what they were working on. By 1944, the project employed more than 130,000 people and had a budget equivalent to $30 billion today. It was the most secret and most expensive research program in history. The scientists, Oppenheimer, Fermi, and the moral dilemma. At the center of Los Alamos stood a man named J. Robert Oppenheimer. Brilliant, charismatic, troubled. The press would later call him the father of the atomic bomb. Around him gathered a team of legends. Enrico Fermi, who built the first nuclear reactor, Richard Feynman, a genius with a chalkboard and a grin. Niels Bohr, who escaped Nazi Europe to advise the Allies. But not all was triumph. As the project advanced, doubts grew. Many scientists had joined the effort fearing Nazi Germany might get there first. But by late 1944, it became clear that Germany had abandoned its atomic program. So why continue? Why? Oppenheimer, later reflecting on the Trinity test, quoted the Bhagavad Gita, "Now I am become death, the destroyer of worlds." Trinity, the first nuclear explosion. July 16, 1945, before dawn. In the desert, a bomb codenamed the Gadget sat atop a steel tower. Scientists held their breath. The countdown began. 3, 2, 1. A blinding flash, a fireball that rose into the sky. a shockwave that shattered windows 100 miles away. The Trinity test was a success. The nuclear age had begun. Hiroshima and Nagasaki, science meets war. Less than a month later, atomic bombs were used in war. On August 6, 1945, Little Boy was dropped on Hiroshima. 3 days later, Fat Man devastated Nagasaki. Both cities were flattened. Over 200,000 people would die. Many instantly, others from radiation burns and fallout. Japan surrendered. World War II ended. But the debate began. Did it save lives or end them needlessly? Was it necessary or inevitable? Legacy and fallout. Science in the shadow of the bomb. The Manhattan Project unleashed forces far greater than any one nation or one war. It led to the Cold War, nuclear proliferation, and decades of global anxiety. Oppenheimer was later cast out, his security clearance revoked. Many of the scientists would question the role they played for the rest of their lives, but the legacy endures. The Manhattan Project taught us that knowledge can be power, and power has a price. Science gave us the tools, but humanity chose how to use them. The Manhattan Project wasn't just a story of physics, or war, or history. It was a story of people, standing at the edge of a new reality, a reminder that every breakthrough can shape our world in ways we never imagined. If this story moved you, subscribe to Echoes and Atoms, because here we explore the science that shaped our past, and the past that defines our science. Until next time, stay curious,